Welcome to Engineering Out Loud. This is the fifth episode of our series from MECHESOL's MESP Management Development Program. It's titled Case Studies and Organizational Impact of Six Sigma. And today, we're going deep, really deep into how Six Sigma methodologies have, driven some really, really cool improvements in different, engineering and manufacturing organizations, real-world examples, so you can really see how this data-driven approach is actually applied out in the field. For more information on how to apply these principles or to register for professional development, visit mechesolco.com/CPD. So, are you ready to get into it?
I'm definitely ready, yeah.
Okay, great.
It's one thing to talk about, the theories, but seeing how they're actually used and the impact they have in all these different industries, that's where it gets really interesting,
That's right.
What kind of transformations did these companies actually achieve?
Okay, well, let's start with this company. They manufacture curtain walls, doors, and skylights. You might not think that they would need like a process overhaul, but they were dealing with a pretty big inefficiency. They actually had three different processes and completely separate CAD and PLM software for each of their product lines.
Oh, wow. That sounds like, a recipe for, some potential issues.
Yeah.
What kind of problems did that actually create?
Well, three different systems, you're going to have a much higher chance of errors. You're going to be wasting time and resources. And it just increases the overall complexity of everything. It's like trying to navigate with three different maps at the same time, right?
Yeah, it makes sense.
Yeah. So PMC, the consulting firm, they stepped in with a classic Six Sigma goal to reduce waste. Muda, as we call it in Six Sigma, anything that doesn't add value to the process, right? And to improve their overall processes. So their big move was to implement singular CAD and PLM systems across the whole company.
That makes perfect sense. Standardizing those systems would create, a single source of truth for all their engineering data.
Exactly.
What were the key steps that they took to, make this happen?
So they really got down into the nitty-gritty. They conducted audits of all the company sites. They identified the process requirements for every single product. And then they developed standardized drawing practices. Then they converted all their existing AutoCAD libraries, including a move from 2D to 3D to make sure everything meshed in the new system. And then, of course, you need those change management controls, right?
Right.
So that any future process updates would be applied consistently across the board. Plus, a 6-step upgrade method covering software, workstations, and even version control.
Yeah. Version control is huge in engineering. Can you imagine the chaos if different teams are working on different versions of the same design? This highlights how Six Sigma even looks at these small details that have a big impact on efficiency and accuracy.
Yeah, so they ended up with one unified CAD software pulling from a central hub of engineering knowledge. And since the CAD system feeds directly into their PLM software, the data flows seamlessly. And this eliminates a ton of manual data entry and potential errors. What was the result of all that? Well, rework at the design stage practically disappeared, which is huge for bidding. Overall costs went down, profits went up, and they eliminated mistakes caused by those outdated design versions.
This first case really shows how Six Sigma's focus on standardization and eliminating waste can lead to, big operational improvements and cost reductions.
Yeah.
It's about creating that streamlined and more efficient workflow from the initial design stage all the way through to the end.
All right, let's look at a completely different scenario. This story comes from a Midwestern U.S. manufacturing company, and they were running a 247 production cycle with a 65% efficiency rate.
Okay.
Their goal was to boost that to 70% to allow for a more manageable 16-hour workday. This will be huge for employee morale, right? And get this. Every single 1% increase in efficiency was projected to save them $250,000.
Wow. That's a huge incentive. Where do you even begin to look for those inefficiencies? A 65% rate in a continuous operation like that suggests some pretty big bottlenecks. Or underutilized resources. What did their data analysis show?
They went all in on data collection. They tracked everything. The machine, the type of product, the operator, the time of day, everything. After 6 months of analysis, some interesting patterns emerged. Performance varied depending on the product and the operator. But the real eye-opener was the link between efficiency and how many machines an operator was assigned.
That's really interesting. It shows how it's not always about throwing more resources, more machines at a problem. Sometimes less can actually be more if it allows for better focus for the operator.
Exactly. Turns out when operators were juggling multiple machines, their efficiency dropped. Plus, they also saw dips in productivity during shift changes. And operators, they just perform better on certain machines.
Yeah. So what was the solution based on all this data?
It's going to sound really simple. They assigned operators to focus only on the machines that they were most proficient on. That's it.
Wow.
And the impact was pretty remarkable. Within 6 weeks, their efficiency shot up to 73%, exceeding their 70% target, a $1.7 million saving,
Yeah.
and of course, improved work schedule.
This case really highlights the measure and analyze phases of the DMA size cycle. Define, measure, analyze, improve, control, right.
Right.
It shows how you can uncover these unexpected relationships in your data and find simple yet effective improvements. And it really highlights the value of understanding and leveraging your human capital.
Yeah.
It wasn't about investing in more machines. It was about strategically investing in their people.
Now let's head over to Saudi Arabia, where a construction company was building 405 villas. Using pre-constructed panels, now a year into the project, they were 25% behind schedule. So their Six Sigma project focused on one critical metric, increasing the number of panels delivered each day.
Okay.
They were only managing to deliver about 18 panels per day. Their goal was 75.
Wow. That's ambitious. What kind of challenges do you think they were facing?
I mean, a 25% delay on a project that big, it's probably a ton of interconnected issues, right?
Yeah, probably from production to logistics, yeah.
Yeah.
Focusing on that daily panel delivery rate is smart. It gives them a clear, tangible target for improvement.
Right. So instead of one massive overhaul, they did a series of targeted changes across different areas. So on the management side, they brought in 4 new foremen to oversee specific production zones and hired a full-time project quality engineer.
So adding management and quality control,
Yeah.
along with new equipment and longer hours. Clearly a multi-pronged approach to increase production speed and reliability.
Right. Operationally, they made some changes to speed up the construction of each panel, brought in a ready-mix concrete truck, purchased cranes and a concrete bucket, and added a night shift to boost capacity. Then they revamped their inventory system. They reorganized the stockyard for better flow, reduced inventory levels to reduce waste, implemented an electronic system to manage everything.
Defining that process flow and measuring cycle times are fundamental Six Sigma practices. They provide a clear understanding of where time is being wasted and where delays are occurring. This allows you to make targeted changes.
Yeah, and they started diligently tracking cycle times to create benchmarks and measure the impact of all the changes. And of course, you have to define each step of the process. Who are the stakeholders? What are their responsibilities? And all of this resulted in hitting their target. 75 panels delivered daily.
Wow.
To prove it wasn't a fluke, they used internal control charts to show it was sustainable.
The use of control charts is a key part of the control phase in DMAIC. You have to make sure the improvements last, and the process doesn't go back to being inefficient.
For our final deep dive, we'll look at Therma Tru Doors and a logistical challenge in their supply chain. Between Mexico and Indiana, they were only utilizing about 57% of the space in their trailers.
Oh, yeah.
Their goal was to increase that to 90%.
Maximizing trailer utilization is a big cost saver in transportation. Reduce the number of trips required, faster deliveries, and it impacts overall supply chain efficiency. A 57% utilization rate suggests they got a lot of room for optimization.
So the coolest thing about their solution was where they got the ideas from. They actually sought out the input of their employees, the people loading the trailers every day. That perfectly illustrates a core Six Sigma principle. The people closest to the process have the best insights. Empowering them can lead to super effective solutions. Based on the advice from a warehouse supervisor, they adopted a new palletization strategy, and the internal team redesigned the fragile glass racks to be safely double-stacked. They didn't hire an expensive consultant. They used the expertise of their own people. Now, there was a dip in utilization when they first implemented these strategies, but within 6 months, they had achieved an incredible 99% utilization,
Wow.
way beyond their target, and then they implemented a control system to maintain it.
Achieving 99% is amazing. It shows what collaboration and commitment to continuous improvement can do, and these benefits cascaded across their whole business.
They had more efficient distribution, faster deliveries, quicker restocking of shelves, increased revenue, and a smoother receiving process. So what's the takeaway message here?
These 4 scenarios really highlight the versatility of Six Sigma. Whether it's engineering, manufacturing, construction, or supply chains, you can get measurable results with a data-driven approach focused on improvement. Increase efficiency, reduce costs, improved quality. We even saw improved employee engagement.
It's about using a structured method to identify problems, collect data, analyze root causes, implement targeted solutions, and ensure the improvements stick.
It's not a magic solution, but it's a framework for driving positive change.
If you're inspired by these stories and you want to explore how Six Sigma could benefit your organization or your professional growth, make sure to apply, register, or visit mechesolco.com/CPD. So the next time you're facing a challenge, remember these case studies. A structured, data-driven approach might just reveal some pretty amazing solutions. Thanks for joining us for this deep dive.